So yeah, so moving on. So today's class, um, we'll be looking at object-oriented programming, right? As you can see from what we have here, with 10 object-oriented programming. So can you see my screen? Okay, yeah, awesome. So yeah, so let me just quickly go through what object-oriented programming is. First of all, I have to say that there's no one size fits all definition for what OOP is, right? Like different people have different outlook, different opinion on what they feel like object-oriented programming is, right? So, but I think I'll just like define object-oriented programming as a way of writing code around certain structures, right? Where we have these entities that are responsible for their state or their data, right? And then they have method to update or to get that data or that state, right? So I mean, you could actually have heard some people talk about object OOP in relation to classes, right? So OOP, like for example, if in languages like, let's say, Java, I guess, right? The Java relies heavily on classes for its own object-oriented programming style, right? But then one thing like that I should try and clarify is that OOP is not all about creating classes, right? You can actually write object-oriented code without classes, and in fact, even in JavaScript, that we are actually putting our focus on, right? So before there was support for classes, people have been writing OOP style program. So anyways, definition is just good for definition. Like I don't think they even ask you what is definition when you're doing an interview or you're trying to apply for a job. Like it's just for formalities for the most part, right? The main thing is understand the concept, know how stuff works. So yeah, so I'll be going through this list, right? Or maybe not, but we'll try and see how far we can go. So the first thing there is create a basic object, right? So I'm using, for this class, we're not really doing anything, I'm not trying to, there's no complex setup here. I'm using this online editor, Code Mirror, right? So I'm not running code from my VS Code or something. So I'll just be typing the code on the left hand side, and you can be seeing the output on the right hand side, right? So yeah, and also yeah, have you gone through the courses on Free Code Camp? Hello, Casa, can you hear me? Yeah, so I was asking, have you gone through the courses on Free Code Camp? I mean this one, yeah. But this particular section, object-oriented programming, have you gone through it? Okay, so what will happen is that for this class we're going to go through some of those exercises, and we'll try and see how many we can solve right before we run out of time. So yeah, so the first thing I have on my list is a basic JavaScript object, right? So really, JavaScript is actually it's a dynamic language, as we know, and it's actually not very difficult to learn. So now, why do we need an object, right? So we need an object so we can actually group different states together. Let's say, for example, we have two variables in our program. Let's say name equals to Noel, right? And let's say we have another variable. Let's say let's call it height equals to, let's just say 160, right? Now these two properties can belong to a person, right? It can belong to an entity, right? Now to show that kind of relationship, right, we use an object. So instead of doing this, we can just say let person equal to this, and this syntax, open and close curly braces, is how we instantiate objects in JavaScript, right? And you can put the person's name. So let's say name as Noel, and then followed by comma, you can put the person's height as, let's say, 160. Yeah, I can hear you. Yeah, that's true. I forgot to mention, if there's anything that is not clear, just like hit me up ASAP, like on the spot. I'll just quickly like explain it. Yeah, all right. So this syntax here from line 2 to line 5, this is what we call a literal object in JavaScript, right? So you can define a literal object by using the opening and closing curly braces, right? Now, and inside this curly brace, you can have properties of that object. So the first property here is name, second property is height, right? Now you can even have you can actually have methods too, not just property. So method basically is a property that is attached to a function, right? So let's say, for example, let's say talk, right? So we can do console.log this just name says hi, something like this, right? So this talk now is a method of this person object. So here we can say person dot talk, and if I run it, you see that it says Noel says hi. So inside the one thing I want to notice is that inside the method, right, this here, this keyword would reference the object that the method is called on. So what do I mean? When I call this method here talk, right, it is called on this object person. So this here, right, this here at runtime would refer to this person. So it is almost as though we did something like this, PERSO person, you see, but actually we just use this, so it will bind this to the object it's called on, and we'll say dot name, and of course we see that the name here, the name property here is set to Noel, and that's why on the output it says Noel says hi. So yeah, that's that about literal objects. So moving on, let me just comment this out. Okay, so moving on. So now, say for example, we want to create multiple instances of person, right? Because of course there are a lot of people in this world, so we want to create multiple instances of person. With what we have so far, right, the only way we can do that is to basically just like duplicate the object, right? So say something like this, person2 equals to object, and we can see name, let's see Kausara, right? And then we can see height, let's see 150, right? Sorry. And then we can see top. That would be a function that console.log. So it will be this dot name again. So something like this, right? So we can keep doing this now. For every object we want to define, we have to create this again. We have to create this over and over again. I can see that this is not like the best way to go about it. It is very tedious, it is very repetitive. And one thing when you're writing code, you don't want to repeat yourself too much, because when you're repeating yourself a lot, writing the same thing over and over again, there will be possibility of making error, right? And let's say, for example, we want to change the way this talk function work. We have to change it here. Let's say we want to change this to hello, right? Now if all the objects are supposed to adhere to exactly the same logic, we have to come here and change this one too. So you can see that it is actually not the ideal way to do things. So, and that brings us to constructors. So basically, a constructor is a function that we use to create objects, right? Now the way we define constructor in JavaScript is to use the function keyword, right? And then this is just convention. We capitalize the function, right? So this is like just convention basically. So now, since the constructor is a function, we can actually take in parameters. Let's see name and then height, right? And inside this function, we can assign the name to name. I can say to height, something like this, right? So now we have our constructor in place. So how do we use it to create an object, right? So we just say let me use person2 equals to new person, and for the name we can see cursor, and for the height you can see 150, right? So if we want to create another person, we can just do the same thing, but now we use 3 equals to, we can call this Noel, and we can see 100, right? So you can see that this syntax is much more cleaner. And of course we can call method on the person that we just created. You can see person2 dots. Okay, let's see, let me console person2 dot name, right? And if I run it, you see like that puts the name here, right? Even inside of this so basically, yeah, like this just how we can use constructor to simplify the way we create objects. And one thing I want to point out here is that when you call this function, right, you see that we put this new keyword in front of it, so that JavaScript will bind the this inside this function to a newly created object, right? Otherwise, if I had called this thing here without new, let's say I just say person, let me just get rid of this one for now. So if I had called this without new, right, let's see what will happen. Oh, I think I've hit the wrong button. I was trying to do something else. Oh, so that's one thing about all this online. Anyways, let me just quickly define the function again. Right, so this is what we had before, and then I said let's, so I called it without new, and I put the ID as 150. So if I run this, so let me console.log. So if I run this and I check the log, so it said this is undefined, right? So the reason why this is undefined here is because we didn't call this constructor with new, right? If you had run this code in your browser, what will happen is this here would reference the window object, and this is the window object. Let me just quickly open my I'm using and this is the window object. So the window object basically is the global object in web browser. So whatever environment you are on, if you are in Node.js, it will probably point to a different global object. And the reason why this is so is because we are calling this without new. However, we are in an online editor, online environment, right? So inside this online editor, like, there is no global object, I guess. That's why it's returning undefined, right? So the way to solve this is to just type your new, and when you run, you see that it gives you the correct output, right? So I hope so far everything is clear. So we have touched about basic objects, we've touched about method, we've touched about making code more reusable with the this keyword. Like I've shown you, we've touched about the this keyword. Describe a constructor. So basically what we just did here, this function we created here, it's a constructor, right? It constructs an object and it returns that object. Like literally it is a constructor. So the next thing there is use a constructor to create objects. That is basically what we did here. We use this constructor here to create an object, and I can say you can use it, you can call it multiple times, right? I can say let's Noel equals to new person, right? Noel height 160, right? You can call it multiple times, and the object it will create will be different, meaning they will have different states, right? And like I said, that's the whole point of object-oriented programming. You have these entities that have different states, and they are actually in a way responsible for their states, right? So you can call it multiple times, and then you have different objects, and all of them have different states. So by state I mean the data that they hold. If I say, for example, node.name, yeah, and I come here and I say don't say .name, right? You see that they will all output their own states here. So their states are different, even though they were constructed with the same constructor, right? They were initialized with different states, so their states are very much different. So yeah, you see extend constructor to receive arguments. So honestly I think we have even jumped ahead of ourselves, right? So now we have this constructor. The constructor takes in argument basically, right? So this is like we already done that, right? So these are the arguments, name and the height, that you pass to the constructor, and it uses argument to initialize the objects. So verify an object constructor using instance of, right? So instance of So yeah, so this instance of it's a it's a it's a JavaScript what I say JavaScript built-in operator, right, that tries to show it tries to show the, let me say, the constructor from which an object is constructed, right? So let me say, for example, I have another constructor here. Let me call it anime, right? This dot is, so this constructor does not really do anything much. You just construct an anime, right, basically, and you can pass in an argument here, and we can assign the name to that argument, right? So now I have, let me construct an anime, for example. Let me call it animal. It's animal. Let me just say dog, for example, equals to now call this dog, right? So now this animal here is the constructor for this instance. So the object at the instance dog, right? And this this person here is a constructor for these three instance. So there are sometimes in our code where we want to know, right? We want to know the constructor from which an instance was constructed, right? So that's where we use the instance of operator. So we can say, for example, let's say person dot instance of, right, person. Let me comment all this one out, right? And let's run it, and I see that it returns true. Right, now this is true because this person here was constructed with this constructor. Now if I say console.log, let's say dog instance of animal, that will still be true, right? Because of course this instance here, which we call dog, was constructed from this constructor. But let me now try to do this. Let me say person instance of animal here, and we can see that it returns false, right? So the instance of operator basically tries to tell you, it tries to ascertain that an instance was constructed from a given constructor. So it's a by what is the word, by basically it's an operator that takes two arguments. On the left the instance, on the right the constructor that constructed the it could be any constructor basically, but if it is the constructor that constructed the instance, right, it will return true, otherwise it will return false. So verify constructor, understand own properties, use prototype to reduce duplicates, iterate about properties. Okay, so I hope you understand all that we have done so far, Kausara. I hope you understand all we've done so far. All right, so now, okay, no problem. So now the next now I'm about to show you might be a little bit tricky, right? It might be a little bit tricky, so you have to watch closely. First I would erase everything I've done here, right? And now I will define an object, right? and this is an empty object. So an empty object, meaning there are no properties in the object and there are no method in the object, right? No property, no method, is an empty object. But now let me console.log object dot to string. Now what's happening here? You can see that I'm calling a method on the object, right? But I've not defined any method inside this object, and in fact when I run it, it gives me a result, it gives me an output, and it says object. That means indeed there's a method here inside this object. Okay, yeah. So first of all, I was saying you have to pay close attention here so you can fully grasp what I was trying to show you. So I defined an empty. Now I'm coming to prototypes. I'm trying to explain prototypes here, right? How prototypes works in JavaScript. So it's a little bit, there are some nuances to it, but it's not that difficult to get. So now I defined an object, right? An empty object. That's your point here. I defined an empty object. This object does not have any property, does not have any method. Meaning I cannot, for example, if I say console.log object.name, right? It should not output anything. True or false? True, right? Because this name here is not a property on this object. I didn't have said, okay, name, let me say my objects, right? Now if I want this code, we should see my object, right? My object, exactly. So now I remove the name, so I didn't put any property on the object, right? And when I run this, it says undefined, which is correct. There's no name on the object. It should be undefined, and indeed it is undefined, right? Now I was saying that this object does not have any method to it as well, right? There's no property, there's no method. But now I call the method to string. If there's no method on the object, it should probably say undefined, or maybe throw an error or something, right? But when I call to string on the object and I run it, it actually gives me a result. So what does that mean? It means that this property here is actually inside this object, but we can't see it, we didn't define it, but JavaScript added it for us, right? Now why is this so? This is because of what we call, this is a concept in JavaScript that we call prototypes. So what prototypes are basically, it's like a fallback, it's a fallback mechanism that JavaScript uses to look for properties or method that does not exist on the object, right? When I call this method to string on this object, of course we can all see that I didn't define any method to string here, right? So what JavaScript does is that it falls back to the prototype of that object. And what is the prototype of this object? You may ask. So every object in JavaScript has a prototype that is called object prototype, right? If I console.log it, let's see what it gives us. It gives us an empty object, but yeah, you see that it actually does it doesn't give us all the property inside this object. But the point is, I think is the way this editor is actually implemented, right? If I use it in a web browser, maybe you can try it out later, you see that there are some properties inside this object. But the point is, what I was trying to show you is, so we have an object, right? We call the property on this object. The property does not exist, so JavaScript will fall back to the prototype of this object, and every object in JavaScript has object.prototype as their prototype, right? So this is like the base object from which all other objects right, derives from. For example, if I say object dot get prototype of objects, like console.log so basically it doesn't give us the whole but okay, you know what, let me just show you. Let me quickly open up my browser console here, right? So what I did here, I defined an object. Let's see, object equals to this, right? And I say, so to get the prototype of an object, you can use the get prototype of, right, object, like this, and see it gives this object that has some property. Now if you look at this property, you will see to string here, right? Now the reason why when I call toString on that object it returns something to us is because JavaScript pinned down to this prototype and called this method toString on that object. So prototypes basically are like how we can they are basically how JavaScript falls back from an object to look up certain property that does not exist in that object, right? So if you call the method a property on an object and the property of the method is not there, JavaScript will fall down. It will fall back to the prototype of that object. So you can see it as, let's say, parent and then child, right? So the prototype is the parent, the child is the object, right? So if you ask the child for something that it does not have, right, it will go down to the parent and ask the parent. If the parent does not have, it will go down to, let's say, the grandparent. It will keep going down until it gets to the last prototype, which is this object here. So this is the thing that every object inherits from. And you can actually see, like if I say, for example, if I say the object one sec. So it's prototype of objects. You can see that it returns true, right? And that's true because object.prototype here is a prototype of our object that we created here. In fact, it's a prototype of any object. But now, you might not. I say this is the base prototype from which everything inherits from. So that means after this thing, there's no other object it inherits from, right? So we can see that by saying, let's say, object dot prototype, right, dot is prototype of object dot prototype, right, and we see that it returns false. So what then? So this function returning false here is telling us that this object dot prototype is the base, right? Beyond this, there's no other prototype, right? And if we get the prototype of that object, just to prove it, so let's say get prototype of objects dot prototype. This is like the last thing in the inheritance chain, right? So if we get prototype of object dot prototype, it will return null. So that means that this object dot prototype here it is not inheriting anything. In fact, it's like a tree, right? We go from the top down to all the objects. Now at the top of that tree, right, at the top of that tree is object.prototype. Beyond it, nothing exists, right? And this object.prototype is actually is actually an object that defines some method in it, right? So basically, if you call a method in an object, right, if it doesn't have that method or it doesn't have that property, it will go and look that property up in its prototype, right? So what I'll quickly show you now is so that was why when we say object.toString, even if there's no toString method in this object, right, it still returns object. Why? Because the method is defined in object.prototype. So it went from object, it went up to object.prototype, and it saw the method there and it called it on this object. So there's sometimes when you don't want this behavior, right? You want to create an object that does not inherit from anything. Let me say for example now you want let's say for example now this was a typo, right? Let's say you have a similar method in your object that is called toString, and you intended to call that method, but mistakenly you called toString, right, thinking it is the method you defined in your object, right? So what will happen now is, like I said, JavaScript will go up to the prototype and look for that method, and if it exists it will call it, and that could be a bug for you because that was not what you intended to do, right? So to define an object that does not inherit from anything, right? So to define an object that does not inherit from anything, right, that does not have a prototype basically. So when we say prototype, we mean what is this object inheriting from, right? What is this, where what ancestor is this object coming from, right? So if I want my object not to inherit anything, right, I'll just say object dot create null, right? Now object dot create takes another object as an argument, and that object will be used as the prototype for the object you're trying to create, right? And by passing null here, we are trying to say, oh, I don't want this object to inherit from anything, just give me an empty object that does not inherit from anything. And let's see what happens when we call toString on this empty object. You see, it returns type error. toString, not a function, right? And this is exactly what we want, because we have not actually defined anything on our objects, right? And if you call object dot get prototype of object, so this returns the prototype that the object inherits from. Now we expect this to be null because we said explicitly here that this object does not inherit from any prototype. If we call this, it will return null. You see, so when you want to create an object in JS and you don't want it to inherit from anything, right, you can use this method object dot create, right? So there are other prototypes in JavaScript, like there is array.prototype, prototype, there is function dot prototype, right? And when you create an array, for example, let's say array equal to this, let's say 1 2 3, right? This array is an object that inherits from array.prototype. In fact, most of the method you call an array, right, let's say array.push, let's say we push 4, right, most of the methods are defined in this array.prototype, and we can see here by saying, we can confirm that by saying console.log, let's say object, right, dot object dot get prototype of my array, right? And let's see what it returns. It returns an array. Oh no, it should return array.prototype. It should return array.prototype. Or you know what, let me just say object dot, okay, let me just say I'll come back to this, but in the meantime, this editor is an online editor, so you have to forgive it for not really. So array.prototype is prototype of my array, and it should return true. And you see here it says true, right? And yeah, I want to put this inside. I need to run this inside my so just like so. Now console.log object.get prototype of array, you can see okay, it returns an array, but basically this array here is the prototype that objects derives from. And in fact, I can see that prototype is array.prototype. Oh no, that's not the syntax, sorry. I went to array.prototype is prototype of array, and that says true. So you can see for the case of array, right, when you call a method like push on it, it first goes to this object, this prototype, array.prototype, before it goes to object.prototype. So there's something called prototype chain, right? The prototype chain basically is basically how an object is how the prototype tree of an object is constructed from the base prototype down to the object, right? So for the sake of array, it goes from the array itself, right, to array.prototype, right, then to objects.prototype. This is how it goes, right? So from the array itself, we should call any array you create, basically any array you create, right? The array will inherit from array.prototype, right? And array.prototype itself inherits from object.prototype. So that's basically how prototype works in array in JavaScript, sorry. And like I said, if you want to define a prototype for an object you're trying to create, right, you can just use object.create, and whatever you pass here would be the prototype of that object. So let me just give you a simple example. Let's see, let me see, we have an object, we call this proto person, right? Call it proto person, and let's say we define a method talk, right? You see this dot, so in the method we just console.log this dot name, right? Then we see says hi, right? So this is an object that has a method that says this dot talk that returns this dot name says hi, right? Now we can construct an object, let's see, Noel, right? I'm set it to object.create. I said the object pass object.create will be used as a prototype for the object that it returns, right? Meaning that now the prototype chain of Noel will look like this, from Noel to proto person and then object.prototype. So that means any method or property you call on this object Noel, it will first check if it exists in Noel. If it doesn't, it will not check this prototype, which is this, which is the object that will pass object.create, and if it doesn't, it will now fall back to this, and after this there is no other prototype again in that chain, right? And now to to verify this, let's add the name to, well, let's say Emmanuel, right? Because we have this name here, right? So now we have with an object, well, we only added name to it, right? But because we set this object as a prototype of Noel, we can call Noel.talk, and if we run it, you see that it says Emmanuel says I. Sorry about the space here. So let me just run it again. You see, right? Now, Noel.talk is not a method that we defined on Noel, but it was defined in the prototype that was used to construct Noel. And in fact, to even prove this further, right? Let's say we have toString here. Now remember the first time I called toString on my object. If you turn this object, whatever, this very obscure output that nobody understands, right? That was JavaScript gave us. Now let's define our own toString, and what would it say? Let's say it will return I am this name, right? So now we have defined our own toString method that returns this string here that is more human readable, human friendly, whatever. So now that means you can come down here, right, and call Noel.toString. In fact, before I call it, let me remove it. Let me comment this out, right? I remember the point I was trying to make here, that because we have defined proto-person as, because we have passed this object to object.create, right? The prototype of our object goes from Noel.protoperson to object.prototype, right? This is what I said previously, right? So now looking at this, when I call toString, right, it checks on Noel, and I've not defined any toString object on Noel. I only defined name. It doesn't find it. It checks proto-person, right? I've commented this out, so it will not find toString here. It will now go back to check. It will now proceed to check object.prototype, and if it finds it, it will return whatever that function returns back to us, right? And let me add console.log quickly so we can see the output. Right, and if you see now that when we run it, it says object. So that is what this toString method returns from the base prototype, object.prototype, right? Now if I comment this out here, right, now what will happen? It checks Noel for it, it doesn't see it, and then it checks this prototype, proto-person, right? And then it sees that, oh, I have a toString here that returns I am this.name. So this.name will be the object that will call the method on, which is Noel, and we'll set the name to Emmanuel. So what we should see here should be I am Emmanuel, instead of this gibberish here that nobody understands. And when I call it, you see that indeed it returns I am Emmanuel, right? So I hope, like honestly, this I think this is quite a lot of information, but I hope you get the point, right? So like, even without using classes, right, we can actually model this kind of inheritance in our JavaScript code. I've not written any classes so far. I've not touched classes. I've not even defined any class, right? I'm just using like the basic primitives that JavaScript gives us to write object-oriented program, right? And most of it are actually based on this prototype here, right? So I hope you guys are following me so far, and so you're using prototype to reduce duplicate code. So basically that's what we did here by defining these guys on this prototype, right? Any any object, right, that extends from this prototype would have this method. So that means we don't have to define it twice. In fact, if I create another object, let's say let me say let me just copy and paste, sorry, object of create, right? So we expect here to have the method to string and talk, and if I add more method here, right, any object you create like this will have that, it will have those method, those properties, whatever, right? So in itself, it actually reduces duplication. Imagine if this was not the case. That means anytime we define an object, we have to add to string talk. Define another object, we have to add to string talk. Imagine we have like 10 methods, we have to add all those methods to every object that we define, right? That would be a lot of duplication. Basically, there's actually another way to do this, but let's just stick to this for now, I guess, so that we don't cause a lot of confusion. So I don't know, any questions so far? Hello? Continuing from prototypes, right? I'm just going to move straight to classes. So the class syntax basically is it's a more easier approach, right, to do object-oriented programming in JavaScript. And I think it was introduced in ES5 or ES6. But basically it's just syntactic sugar, right? And I will show you that in the end, right, all that you actually do with classes, it still transpires down to using prototypes, right? So the classes is just a syntactic sugar on top of what prototypes allow you to achieve. And the nice thing with classes is that it just makes dealing with objects and OOP programming, it makes it a little bit easier, and the syntax is much nicer. So the class syntax goes like this in JavaScript. We use the class syntax, right, to define a class. So I can define a class, say person, right, and inside the class we can have constructors, right? So just like the way we define constructors with functions, right, here there is a dedicated syntax for it, and it is a keyword constructor. So a constructor can basically take arguments, right? Let's say a person should have a name and person should have an age, right? So we can pass those arguments to the constructor. Now inside the constructor, right, we can assign the argument we passed in to properties that an object of this class will have. For example, this dot name equals to age name, and this dot age equals to age, right? So when we create an instance of this class, let's say let me equal to, we say new person, right, and then we'll pass these two arguments, right? I can just say Noel, I can just say age like 99, something like this, right? So now you can see that the object here would have this property. We can log the name, let's say me dot name, right, and when we run it, you see it outputs null. So you can see that using the class, the syntax is much nicer. If we're doing this with functions, we have to be defining functions, remember to put this, but then trying to extend it now, we have to use prototypes and all that. But anyways, inside our class here we can have method, right? So let's define the method. Let's say talk, for example, and inside the method here, this of course still binds to the object that it is called on. You can see so when I talk, we can just console dot log this dot name, right, and we can see says hi basically. So now I can comment this out and then call our method talk, right, and we expect that to be logged. So Noel says hi. So you see that the class syntax is just much neater than dealing with prototypes. But anyways, I did mention that this is just syntactic sugar, right, and under the hood we still use prototypes to represent most of what we do with classes. And to prove that, let's say I want to extend this class here, person, to include, okay, let's say I want to override this method here, talk, right. So let's say I want to extend the class, for example, right, to include another method. I can come down to the prototype, right. So instances of this class would inherit from this object person.prototype. I can add another method. I can say run, right, and I'm just put the function here and just say let's just say I'm running, something like this. But let me just console.log it. Console.log I'm running, right. So and now I can call that method here on the class, right, and you see that person.prototype is undefined. Oh sorry, I made a mistake here. I'm supposed to put T here. Okay, if I call it now and you see that it works, right, you can see that it basically works. So that tells you that under the hood basically, right, the classes are still using prototype. But then if we actually want to extend a class to add new method and we don't want to deal with prototypes, you can do it like this, right. But I mean, the whole point of using classes, I assume, is so that we don't have to deal with prototypes, right. So I'll just quickly go to introduce inheritance. So inheritance is basically how we can extend the definition of a class, right. So for example, you have a class, you can inherit from that class and then add more method to your new class, right, to the class that inherits from the base class. Anyways, so let's say now this thing we did here, adding run to the prototype, right, we can actually do that by just inheriting the class, but then we have to create a new class. So let's say class runnable person, right, and to inherit from a class, I think we use the extend. So we are going to extend person class, right. So now the constructor, we're still going to take two arguments, name, age, right. So in order for us to construct, so in order for us to call, when we extend the class, right, in the constructor, we normally pass the argument to the base class, and the way we can do that is by using the keyword super, right. Now this base class here, person, as you see here, it constructor expects two arguments, name and age. This constructor can take more than two arguments. Let's say we are passing height here, but the most important thing is that when we call the constructor of the base class, right, we have to pass the argument in. We have to pass the argument to it, right. So and then we can of course here say this dot height is equals to height, right. But now the whole point of doing this is to add the method run, right, and the method simply just says so we just console dot log and we say I'm running, right. So we can remove this one here, right? And now we can remove this. And so basically now we have actually created a new class called runnable person that is able to run, right? So to instantiate an object of that class, we can just say new runnable person. But now remember, we put in we also pass an height. We pass a height argument to this constructor, right? Let's just say height 190, right? And now we have extended this class to include the method run. And if I run the code here, it gives us the same output. In fact, let me just put a little bit of ellipsis here, and if I run it, you see that this is actually being called, right? And by virtue of extending this class, we also still have access to the methods that are defined in the base class. For example, it means I can still call the method talk, right? I can still call talk, and my object here should be able to talk. So you see, this is basically how inheritance works, right? So if we're not dealing with inheritance, then we have to add this method to the prototype of this class, which is what every object of this class would inherit from. Remember when I talk about prototypes, like we have the object, we have the prototype, and we have the base prototype. We can actually have more prototype in the chain, but at the end of the day, we end up with the base prototype, which is object.prototype, from which every object inherits from. But this class syntax basically just gives you this nice abstraction over the prototype way of doing things, basically. And so quickly, I'll just quickly introduce the concept of polymorphism, right? For the most part, when people talk about object-oriented programming, right, they talk about encapsulation, they talk about inheritance, they talk about polymorphism, right? So encapsulation is basically how we can hide implementation detail inside our class definition, right? For example, we can add method, or we can add properties of this class that are private, and we will do that in JavaScript is something like this. We use the hash symbol and the name of the property, right? Now outside of this class, this property is not visible. In fact, I can assign this here to something. Let's just say this underscore blood type, right? I can say SS, right? Now outside of this class, if I try to access the blood type here, it should throw an error. You see, undeclared private field or method blood type. So it is only inside this class here that we can basically access this property. We can actually define methods too that are private, right, by using this hash symbol on it. Now remember the last time I called run and we did get a result. So if I call run now, after doing this should throw an error. And if I move this hash here and I try to call it, it shouldn't throw an error, because run, it should throw an error still, because run is not a function, right? Basically we have hidden this implementation from the outside world, right? And this thing might be something that we actually use to construct something else, or maybe do some complex logic inside the class. But basically we don't want external, we don't want things that are external to this class to be able to touch it, right? Maybe so as not to corrupt some state or something. So basically we can just like hide those properties that should not be able to be called from the outside, from the outside of the class, right? And inheritance basically is how we can extend the properties of one class, which we call the base class, to another class that inherits from that class, right? So for example here, you can see that this class runnable person basically just extend from this class. And the third one is polymorphism. So polymorphism is simply let me just clear this out. Polymorphism simply is I think the best way I can describe it is having a piece of code, for example, right, that is expected to work or operate with different kind of objects, right, so long as they satisfy a particular constraint or a particular interface, right. So basically it is more like you can have a function, for example, that can take any object, right, and it doesn't really care about what exactly the object is, what class the object what class created the object, right. So all the function cares about is that the object satisfies a constraint, an interface, and if it does so, it is going to work with that object. Now, a simple example of that is, let me call string, right, and let me pass my object that I created, me, to string. So if I log the output, if I log the output of this, right, so what string does, basically it takes in an object and it converts that object to a string. Simple, right. So we take an object and it converts it to a string, and when I log the output here, I'm typing, so this is what we get, object. Now you can guess why this is giving us object, right. I think you can guess why if you have followed all we have said from prototype to this point. You see that every object, right, okay, let me rename this to Noel. So every object in JavaScript basically have this prototype chain to it, right. And now in this object, when you look at the class that created that instantiated it, and the class that it extends from, right, there's really no function, there's really no toString function that was defined in that inheritance chain, right. So when you pass this object to this string function, right, it basically looks up the prototype chain of that object to find the method to string, right. And the first instance of this method that it finds, it calls it on this object. And in fact, we say that this toString method is defined on the base prototype from which every object in JavaScript inherits from, which is object.prototype, right. So it goes through the prototype chain of this object, and when it gets to this point, it sees the method and it calls it. And in fact, we're talking about polymorphism, I'm saying that any object basically can be anything, right, that defines it to a string method. We can call it, we can pass it to this function. So if we basically come here and define our own toString method, let's see, toString, and we just return let's see, so I am this dot name, right. Now all we have done basically is to add this method to our class, right, and when we pass it to this string function here, we see that we basically call it, and we have the output like this, right. So this is really what polymorphism is about. We can actually have another class, maybe we can have another class like class, let's see, can you see plain, right, and we can instantiate this class with as many methods as we want. Maybe we can have a class, we can call it vector, right. It doesn't really matter. This guy here does not really care about what exactly the instance of the object you are passing to it is. All it expects is that that instance implement an interface. Now you see that since we have not implemented anything here, it will call the toString on the object.prototype, right? But if we have implemented a vector here, right, if you have implemented a toString in this vector class, it will call that. So the whole point is, the way polymorphism is, right, it just means that we are not really concerned about the type of object, right, that is passed to that function, to that routine, right? So all we actually care about is that that type does satisfy some constraint. It can be one, it can be two, it can be many, right? So as long as it satisfies those constraints, right, we are able to work with that type. So basically, I have introduced the concept of encapsulation, the concept of inheritance, the concept of polymorphism, and then the concept of classes in JavaScript, right? I hope that this gives you a foundation to continue to learn about object-oriented programming. So yeah, I'm going to stop the recording so as not to bombard us with too much information. So yeah, we would end this for now, and our next class would continue. Thank you.